So first problem is A comma A1, A2, A3 and so on A9 comma B are in arithmetic progression. A comma G1, G2 and so on G9 comma B are in geometric progression. A comma H1, H2 and so on H9 comma B are in harmonic progression. If A and B are the roots of x square minus p plus 1x plus 16 equal 0 where p belongs to R, then find the value of product R equal to 1 to 4, A R H 10 minus R, G 10 minus 2R. You have to find the value of this. Next, second problem. Of all the system of equations in xyz of the form ax plus by plus z equal to c, x plus y equal to d, y plus ez equal to 1, formed by choosing a, b, c, d from the set 0, 1, 2, 3 and so on up to 8 with replacement. The probability that it does not possess a unique solution is of the form 2 power m upon 2 power n in lowest terms where m and n are natural numbers. Then find the values of m and n. So in the first problem, A1, A2 and so on An comma 9, A9 comma B are in arithmetic progression. So the total number of terms are 11. So B is the 11th term in arithmetic progression. So B equal to first term A plus 10 into D. So D equal to B minus A upon 10, where D is the common difference of the first arithmetic progression. Then you can write A1 is the second term in this series. That means A plus B minus A upon 10. A2 will be A plus 2 into B minus A upon 10. So in that manner, A R will be A plus R into B minus A upon 10. In the same manner, A G1, G2 and so on G9 comma B are in geometric progression. Then GR can be written as A into B minus A to the power of R by 10. And for the harmonic progression, HR equal to 1 upon 1 by A plus R into A minus B upon 10 AB. Now, using HR, we can calculate H10 minus R, and using GR, we can calculate G10 minus 2R, and product R equal to 1 to 4. If you simplify, you'll get AB to the power of 6, but AB is what product of the roots, which is 16. That is 16 to the power of 6, which is same as 4 to the power of 12. The options are first option 16, second option 64, third option 4 power 9, fourth option is 4 to the power of 12. So correct answer is D. In the second problem, it does not possess a unique solution is 2 to the power of m upon 3 to the power of n in lowest terms, where m and n are natural numbers. Now, when the system of equation does not possess a unique solution means the determinant must be equal to 0. That means when you simplify, you will get b minus a into e equal to 1, but a, b, c, d all are integers only 0 to 8. So e must be equal to 1 and b minus a also must be equal to 1. So satisfying b minus a equal to 1, you can have 8 pairs and e equal to 1 is fixed. So probability that delta equal to 0. For A and B, only 8 possibilities, that is 8 cases. For C, 9 possibilities, 0 to 8. For D, also 0 to 8. And for E, it is only 1 in the denominator. Total possibilities, 9 to the power of 5. So it is same as 2 to the power of 3 upon 3 to the power of 6. That is m equal to 3, n equal to 6. Third problem. If a biased coin is tossed n times such that getting a head is thrice likely to appear than tail, let Pn be the probability that no two consecutive heads appear. If the recurrence relation is A Pn equal to B Pn minus 1 plus C Pn minus 2, then find the least value of A plus B plus C. So the fourth problem is let A bar equal to I plus J plus K, B bar is I minus J plus K, C bar dot A bar equal to 1, and A bar cross C bar equal to B bar plus lambda A bar. Then first option, scalar triple product of A bar, B bar, C bar is minus 8 by 3. Second option, lambda is minus 2 by 3. Third option, scalar triple product of A bar, B bar, C bar equal to minus 7 by 3. Fourth option, lambda equal to minus 1 by 3. This is a multi-answer. Fifth, triangle ABC with a right angle at A inscribed in hyperbola xy equal to c square where c greater than 0 such that slope of BC equal to 2. If distance of point A from center of xy equal to c square is root of 10, then first option c equal to 2, second option c equal to 4, third option equation of normal at A is y equal to x minus 3 root 2, fourth option equation of normal at A is y equal to 3x plus 8 root 2. It is also a multi-answer. So in the third problem, it is a biaxed coin is mentioned, and getting a head is thrice likely to appear than tail. Means probability of getting a head is 3 by 4, whereas probability of getting a tail is 1 by 4. Now, because here tossing n times, if I consider nth toss, so the nth toss can be head or tail. So nth toss can be head or tail. Again, I can consider as if nth toss is a head, then first n minus 2 tosses should not get two consecutive heads, and n minus 1th toss must be tail. That means this again you can express in terms of P notation, that is Pn notation you can write. So nth toss can be tail. Then first n minus 1 tosses should not get two consecutive heads. That is, we are trying to write the recurrence relation for Pn. That means Pn corresponds to what? Probability that no two consecutive heads appear. So we are splitting into two parts. That means Pn again can be written as, using the first part, first n minus 2 tosses should not get two consecutive heads, means Pn minus 2 into n minus 1 the toss must be tail, so the probability is 1 by 4, and nth toss is head, so probability is 3 by 4. Or second case, that is plus n minus 1 tosses should not get two consecutive heads, that is Pn minus 1, and nth toss must be a tail, so the probability is 1 by 4. That is, you are writing Pn in terms of Pn minus 1 and Pn minus 2. Now, if you simplify, it is in the form of A Pn plus equal to B Pn minus 1 plus C Pn minus 2, where A equal to 16, B equal to 4, and C equal to 3. So the least value will be 23. Now, so the options are A, C, and D. It is a multi-answer question. In the fourth problem, A bar cross C bar equal to B bar plus lambda A bar. So take cross product with A bar and dot product with A bar and simplify. Then you'll get scalar triple product of ABC as minus 8 by 3 and lambda equal to minus 1 by 3. So another general method is you can take C bar as xi plus yj plus zk and apply the conditions and simplify. In the fifth problem, the rough figure will be like this. Is a rectangular hyperbola xy equal to c square. So there is a one property that you can prove it as, once if it is a right angle triangle is inscribed in a rectangular hyperbola, you can prove that normal at right angle will be parallel to BC. So take the parameters T1, T2, T3 and calculate the slope of the normal at A and calculate the slope of BC, and then you can prove that normal at A is parallel to BC. So after that, because the slope of BC is given, so calculate the slope of the normal at A, which will be T1 square equal to 2, and distance of the point A from the center is root of 10. So another equation will be C square upon T1 square equal plus C square T1 square equal to 10. So if you solve, you will get C equal to 2. Then you calculate the equation of the normal at A, which will be y equal to 2x minus 3 root 2. So the options are A and C. So the next one is paragraph. Let there are m seats in a row, out of which n are to be occupied by n persons, given m and n are even numbers. N factorial, second option. Nc m minus n into n factorial, third option. M minus n plus 1 cn into n factorial, fourth option. Nc m minus n into n factorial. Next problem. The number of seating arrangements such that each person has exactly one neighbor is, first option, m minus n pn. Second option, m minus n by 2 cn by 2 into n factorial. Third option, m minus n plus 1 cn by 2 into n factorial. Fourth option, not possible. So second paragraph is let x minus 5 plus 1 equal to 0 be axis of parabola. X plus 5 minus 4 equal to 0 is a tangent of the same parabola at its vertex, and 2x minus 5 plus 3 equal to 0 is another tangent to the same parabola in that first bit. If equation of directrix of parabola is of the form Lx plus My equal 29, then find the value of L plus M. Another problem is if the length of lattice sectum of parabola is root 2 p by q, where GCD of p comma q is 1, then find the value of p plus q. Now, here also you have some properties. If you recognize the properties, it will be easy. Otherwise, it will become lengthy. So, out of m seats, n persons has to sit such that no two persons sit side by side. So, let us denote the variables x1, x2, and so on, xn plus 1. x1 is the number of vacant seats before the first person, and x2 is the number of vacant seats between the first and second, and so on. Xn plus 1 is the number of vacant seats after the last person. Now, x1 will be greater than or equal to 0, and x2 to xn will be greater than or equal to 1, and xn plus 1 greater than or equal to 0. And sum of all these variables will be m minus n. Now, if I add 1 to the first variable and 1 to the last variable, then right side will be m minus n plus 2. So, which will be same as number of positive integral solutions of the equation, which is m minus n plus 2 minus 1 c n plus 1 minus 1 into n factorial. That n factorial corresponds to persons arrangement, which is same as m minus n plus 1 cn into n factorial. Next, in the next problem, number of sitting arrangements such that each person has exactly one neighbor. That means each person, when you want to have only one neighbor, means you group two persons together. So two persons together, and these two persons should not be consecutive. These two persons should not be consecutive. Then you can say that exactly one neighbor will be there for each person. So persons, you pair it such that no pair is consecutive, and you can apply in the same manner. Then you'll get the answer is m minus n plus 1 c n by 2 into n factorial.